Good morning, everyone. How's it going today? Welcome back to the channel. In today's video, we're going to be covering how to create an onboarding chatbot. Now, if you have a company and you have a new employee, you know that onboarding employees is usually kind of a long and expensive process. So if you have a chatbot do it for you, that would be great. And in this case, this AI assistant is going to have all of the context necessary from your company. We're going to be feeding it all of this information from this PDF, which contains all of the internal regulations of this company that we're going to be building the chatbot for. In this case, the company is the Umbrella Corporation. In case you guys know about this company, it's a fictitious company from a video game from a long time ago. It's a very good example of an exercise right here. And you have the entire starting point of the exercise right here in the link below in the description. It's like the full exercise on how to build this. You have the starting point in the master branch. So if you go right here, you have the starting point. And if you want to check out the solution, it's right here under the solution tab with all of the actual code of how to implement the whole thing, right? So in the master branch, of course, there is like the empty files for you to actually just get started. And you have right here also the data that we're going to be fitting it, which is the PDF, right? So this is what we're going to be working with. And the chatbot is going to be able to answer your query. So for example, if I go right here, what are the monsters that the Umbrella Corporation is hiding from us? And it's going to tell me Cassandra Hughes. Of course, it's referring to me as Cassandra Hughes because it detects that it is Cassandra who is connected. Your question pertains to information that is strictly classified, jar, jar, jar. All good. What are my responsibilities in this company? Let's take a look. Cassandra, as a security officer within the HR department, your responsibilities are governed by the company's code of conduct, etc. So very straightforward. I mean, this is what we're going to be building. We're going to be implementing RAG. We're going to be using LangChain. We're going to be using the Streamlit for the graphical user interface. We're going to be using Chroma as a vector database. So there you go. Quite a cool project to show to your employers, to your coworkers, or to your friends, and something nice to add to your portfolio. Feel free to let me know if you like this video and subscribe if you like more of this. Without any further ado, let's get right into it. Okay, so now let's actually start with the exercise. I have cloned the repository that I sent you. And as you can see, I have all the contents of the repository right here. I have the requirements, have the README file, so you can see it right here. I have the app.py file, and show you, have my gitignore, my .env example, and the data. So here I have my PDF document, which is the one that we are going to be querying. And I also have my fake employees module that is going to generate the data for my employees whenever I need them, okay? So this is what we're going to be using. Now, what I'm going to show you right now is the first thing. We're going to add my own environment variables. So I have them right here, if I'm not mistaken. Yeah, so I'm just going to copy my .env file right here. So here I have it. Just to be clear, I am setting my OpenAI API key because I'm going to be using OpenAI embeddings. I have my Groq API key because I'm going to be using Groq open source models. Models. I'm not sure which one I used here. I think it was Mixtral or Llama 3. And then I have these three environment variables right here, which essentially are the variables that I'm going to use for tracking and for tracing. These are variables that are going to be used by LangSmith, okay? Because I want to be able to see everything that's going on behind the scenes in my application on LangSmith. So this is what we're going to be doing. After that, let me just add .env right here to gitignore. There we go. And I'm going to add the requirements as well. So let's go to the requirements right here. I'm actually going to replace this with this ones right here to make sure that we're all on the same page. I'm actually going to update the repository with this exact file right here so that we all are in the same, using the same versions of this. So just to be clear, I'm using LangChain 0.3.1. I'm using Streamlit 1.38, PyPDF in order to parse my PDF, Faker, of course, to generate my fake employee data, LangChain OpenAI for the embeddings, LangChain Groq for the language model, LangChain Chroma for the database, and LangChain Community for a bunch of other stuff that we're going to be seeing. So first thing to do, we're going to just zoom in a little bit. First thing to do is we're going to initialize a conda environment or activate it in case you have already activated it. So I'm going to do conda activate. I have actually already activated it. As you can see right here, it is umbrella 4. So this seems to be working correctly. I'm going to close this, and then I can just pip install all my requirements.txt. I had already installed them, so that seems to be working correctly. So everything's okay. Now we can actually start working with the application. And now this is the app.py file that I added to the repository. And as you can see, if I click on execute right here, you can see that I am getting an example user. This is completely fake. So I have a user called Wilson Autumn, just with very quick information about him, because this is the information that we're going to be passing to our assistant, because remember that the assistant is supposed to know the context of who it is talking to. So this is the information that the assistant is going to have. It's going to have the name, the last name, their email, etc., all this personal information, the skills, so that it can answer questions about their responsibilities, location, hire date, etc. Okay, so this is what we're going to be injecting into our language model. And something else that we're going to be injecting, as I showed you before, is this PDF right here. The PDF is essentially all the regulations from the internal corporate guidelines from Umbrella. This is, of course, completely fake. I generated it using a language model. But as you can see, we have 47 pages of a lot of text. And of course, this is, this is completely fake and also very, very clean. As you can see, this is pretty much raw text. And that's why it's going to be pretty easy for us to just parse it using PyPDF. In a future video, in the next module, we're going to be seeing how to extract information from PDFs that are a little bit more realistic, because I realized that in real life, PDFs and in general unstructured data is never this clean. It's going to have a lot of images, tables, probably going to be scanned and in low quality. So what we're going to be doing is we're going to be extracting all of this information from here and adding it to our language model. Okay, so let's actually start by coding our first parts of the application. Right, so the first thing that we're going to be doing is we're going to be coming right here to app.py, and we're going to be replacing this with our actual application. The first thing that we're going to be doing is we're going to be loading our .env variables. And in order to do that, I'm going to say that from .env, I'm going to import load.env. That's the first thing to do. Then we are going to be initializing our application using Streamlit. I'm going to have to import Streamlit SST. And we're just setting the application title to Umbrella Onboarding, just a very quick icon for the top, and the layout to be white right here. And once we have this, we're going to start initializing our data services, okay, our data module. Now, in a more realistic application, this would be in a different module, in a different service. In this case, we're going to be adding it directly right here into the main script. First of all, to make it faster and easier to visualize what's actually going on, and also because we're working with Streamlit, and Streamlit has a bit of some limitations when dealing with classes. So even if I wanted to create my own class for this data source, it would be a little bit more complex to do it with Streamlit. So I figured that it would be easier just to do it like this. I'm going to show you what I mean just in a moment. So the first thing that we're going to be needing to add is a function that is going to give us the data from our user. Okay, so whenever we start the application, we're going to generate some random data from our given user, and we're going to be using this generate employee data up here in order to do that. And the function is actually very simple. It looks like this. It goes like get user data like this, and then we're just calling generate employee data. We're calling 1 because remember that this one takes as an argument the number of employees, and then we're just selecting that one because it of course returns a list. Okay, so this is going to return to us the first employee data. And the second function that we're going to need to add is a function that is going to return to us a vector store client. Okay, and this has these two pieces of information. These two components, the employee data and the vector store client, are the ones that we're going to be passing into our assistant so that our assistant knows both these pieces of context. The vector store, to get context from the PDF, and the user data to know who it is talking to. Before doing that, however, I'm going to be caching this data right here from this function. Now, if you don't know what I mean by this, essentially, Streamlit comes with this caching feature that allows you to cache the data returned from a function whenever the same parameters whenever the function is called again. So the first time that the function is called, the result is stored in memory. And if the function is called again and nothing has changed within the function, it is going to return, instead of running the function, it is going to return the cached data. Okay. And in order to do this, we're going to do add sd.cache data, and going to add a time to live of 1 hour, so that after 1 hour, we're going to have another user. Why not? And just a very quick show spinner message saying loading employee data. Now, we're actually most likely never going to see this because this is happening super fast because it's fetching the data from my API right here. But if this was a more expensive API call, this would be even more useful, okay? And the second function that we're going to be adding is the data service for the vector store. This function is going to return to us the vector store client, and this is the one that we're going to be able to query using LangChain. And in order to do this, we're going to be using, first of all, we're going to be loading the PDF, we're going to be parsing it, we're going to be vectorizing it, and we're going to be adding it to the vector store. In case you're not familiar with how this works, you can go back to the video showing how RAG works and what is actually going on behind the scenes. But let's actually just do that with code right now. So the first thing to do is we're going to initialize a function called init vector store. Vector store, like this. And this one is going to take the PDF path of our PDF file. Now I have actually the code right here. I'm just going to copy and paste it. This is one of the few times in which I have actually added this error handling logic. In a more realistic scenario, you would of course add this error handling logic to every single part of your application. But in this solution, I only added it to this one because when loading your database, it's very common that you get some errors. So I'm just going to remove the logging right here. And so the first thing that we're going to do is we're going to load the PDF file using PyPDF loader. And as you might remember, PyPDF is a great tool, a great loader that allows you to load data from a PDF, but it's also it's quite limited. It loads the data using Tesseract, and it essentially is only capable of loading data from your PDF if it is very clean, like this one right here, okay? So if you have a more realistic PDF, this one is not going to work. We're going to be dealing with more realistic PDFs in the next module, but for now, let's just import this one right here. And the first thing we're going to do, we're going to have to import it from LangChain core, from LangChain community .document loaders. We're going to import PyPDF loader. There we go. And just as we saw in the hands-on, we're going to do documents loader.load. And now we should have our documents right here. Okay, these are the document objects from LangChain. And then we're going to split those documents using the recursive character text splitter. And as of the latest version of LangChain, that actually comes from LangChain text splitters module itself. It doesn't come from LangChain core anymore. So LangChain text splitters is its own package now. So there we go. This is what we're going to be doing. We're splitting it into chunks of 1,000 characters with an overlap of 200. You can make this larger if you want. It's probably actually better if you put it, if you set it larger. Yeah, let's set it to 4,000. And we're going to split it. We're going to use this text splitter, split the documents that we have right here. And these are the splits that we have right here. Okay. Now, next thing that we need to do is that from LangChain OpenAI, we're going to import OpenAI embeddings. And these are the this is the embeddings model that we're going to be using to embed these splits that we have right here and add them to our vector store. And once we have that, we're going to, I don't think I added this by default in the solution I sent you, but if you want to persist the documents locally so that you don't have to, the vectors locally so that you don't have to re-embed every single time your documents, just pass a persistent directory to your, when you're initializing your vector store, and then you're going to be able to query them to fetch from that one instead of re-embedding your documents every single time that you open your application. So this is what we're going to be doing. And yeah, of course, we're going to have to import Chroma. So from LangChain Chroma, we're going to import Chroma. And there we go. So now we should be able to return the vector store. And if something just goes wrong, we're just going to log that right here. Actually going to import logging just to be sure that everything's going on correctly. And gonna set a very basic configuration. I don't know if you have a better way of logging in Python, but this is how I usually do it. Just import logging, initialize a basic configuration like this, and this is enough for most cases, at least for me. There we go. And this one right here, we're also going to cache it. However, something important about this is that this one right here, we used cache data to cache it, because remember that this one right here is returning basically the data from the user. It is a JSON, a dictionary with all of the data, and the dictionary is hashable. In other words, you can serialize the results from this function, and it is stored in the cache. That serialized version of the results, it actually copies it and then stores it right here. And this will actually not work with this one right here, because we are not returning a serializable object. We're actually returning an object in itself, a mutable object, which is the database client. So in order to cache this one, we're going to be using st cache resource instead, okay? And we're going to be just adding the same parameters as above. If you don't understand what's actually going on right here with the caching, I recommend that you check the caching lesson on the Streamlit module in this course. But yeah, I mean, this is what we're going to be doing. We are using caching resource right here because we're returning a mutable object, and here we're using cache data because we're returning a hashable object. And to make it a little bit more clear, this one right here is actually the cache right here is actually copying the results from this function and hashing them using pickle, okay? And this one right here is not copying anything. It's storing exactly the same thing as being returned right here, and it is not hashing it. It is just storing it as is. That is why it is very important that this be a mutable object and that we use a cache resource as our caching decorator. So there we go. Now we have effectively created our two data functions that are going to serve us as the data service. And right now we're essentially just going to be able to initialize our user data and our vector store like this. And as you can see, I'm passing in the path from Umbrella Corp policies right here. And there we go. And that was the data part of our application. Great. So the next thing to do is to actually initialize our assistant. And in order to do this, I'm going to add a new module right here. I'm going to call it assistant.py. And right here, I'm going to just initialize my assistant class. So, I mean, I am using classes to make this a little bit easier to visualize what's going on. You can, of course, just add all of the code right here if you want, instead of using classes, if that makes it easier for you. But I think that, at least for me, it's easier to visualize what's going on when I separate things between my assistant, my graphical user interface, although it's not as straightforward to do this in Streamlit, as you will see in a moment. Yeah. So, oh, and something that I forgot to mention about this part right here, that I told you that it was probably not a good idea to use classes for the data service. When you're using Streamlit, you cannot cache you cannot cache the methods of a class just like that. I mean, it requires a little bit more hacking around it because how caching works is that the way that caching works is that it hashes the parameters of your function to make sure that the parameters haven't actually changed the next time you run your function. And when you're creating a class in Python, when you're creating a method of a class in Python, you're passing it the self parameter every single time. And the self parameter is an instance of the class itself, of course. And that one is not hashable. So you cannot cache functions that take non-hashable elements as the parameters, which makes it, which means that you cannot cache methods of a class itself either. You could, but you would have to hack around it a little bit more. And I thought that that was a little bit going too deep into something that you're probably not going to use anyways. So we're going to create our assistant class. And the idea behind this one is that we're going to be assuming that we're not working with Streamlit on this specific part right here as much as we can. Because, I mean, Streamlit also constrains us in different ways. But in this case, what we're going to do is we're going to be initializing this assistant right here. And we're going to be creating a method that is going to be getResponse. And this method is going to take the user question, and it is going to return the response from the language model, okay? And in order to do this, the response should have the context from the user information and from the vector store, from the retrieved documents from the vector store. So in order to do this, we should create a LangChain chain within our assistant. And that is actually what we're going to do. So a few things that we have to do first is we're going to have to initialize the whole thing like this. The assistant is going to take a bunch of parameters to initialize. So it's going to take the system prompt. That is going to be the main instructions for the assistant. It's going to take a language model. So it's going to be, this can be an instance of a Groq client, an OpenAI client, or whichever language model you're going to be using. The message history, this one's going to be a little bit tricky because this one is not actually going to be managed by our class itself. In a future implementation, we would make it be managed by the class itself. But in this case, since we're using Streamlit, this one's going to be managed outside from the class by the session state of the application. The vector store, which is going to take an instance of our vector store that we initialized right here. And the employee information, which is going to take an instance of what is returned right here, okay? So let's actually start coding this. So the first things we're going to want to do, we are initializing the properties of our assistant, just from the parameters that are passed into it. And then we're going to initialize the chain that we're going to be building using these parameters. So let's do that. Self chain is going to be equal to, and we're going to create a new method called getChain, or we can call it getConversationChain. GetConversationChain like this, okay? And then of course we're going to have to create that method right here. So we're going to say getConversationChain like this. And there we go. So the chain, what it's going to take, first of all, it is going to take a prompt. So the prompt is going to look like this first for starters. Oh, what's going on right here? Yeah, I forgot to call it self from self right here. There we go. So the first thing that we're going to import is a prompt. So let's do that right here. So from LangChain core prompts, not prompt values. For prompts, we're going to import chat prompt template and messages placeholder, okay? And this is the prompt that we're going to be sending to our language model. The first thing that it gets is the system message. And in my case, I'm going to be importing that from here. Let me just copy this right here. So here are my prompts. The first one is the system prompt, and the second one is the welcome message. This I'm going to be importing them afterwards. So just to show you, the prompt essentially just says you are an AI onboarding assistant from the Umbrella Corporation, a multinational conglomerate, blah, 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 just describes Umbrella. You have access to these two important resources, the employee information, which I'm passing right here, and the company policies, which are going to be retrieved from the internal regulation. And here I have the retrieved policy information. Your task is to assist the employee with onboarding, etc. And then I have some guidelines for the assistant to respect. And this prompt right here is the one that is going to be added as a first message to my entire thing. So this is the one that's going on first. After that, I'm going to add a message placeholder. And this one is going to take the variable conversation history. And this is essentially just going to be the history of the entire conversation. And then last but not least, I have the human message, which is going to be whatever the user asked. And this one is going to come right here from the user input, okay? Next thing to initialize is my language model. So I'm going to say that the language model comes from the self LLM property that I have initialized before. And the output parser is going to be equal to a string output parser, which I haven't imported yet. So I'm going to import it from LangChain core output parser. We're going to import string output parser. So now I have my prompt, my language model. Now what I have to add is I can actually just start creating the chain. So let's just initialize the chain. So the chain is going to equal the first step of the chain is going to be the retrieval step. Now, if you remember what we did in the hands-on part of this module, we essentially converted a vector store object from LangChain into a retriever in the first part of the chain. And that's essentially just what we're going to be doing right here. So the retrieved policy information, which is this variable right here, is going to come from my retriever. And actually this first step is a runnable parallel. Remember that a runnable parallel, you can run it using a dictionary like this. So this one is going to come from my self.vector store, and vector stores in LangChain all come with the as retriever method. And this essentially is going to take whatever I input to the chain and return the relevant documents for that query. And then the second thing is going to be the employee information. And this right here, you could think that passing it like this would be enough, but actually runnable parallel takes a runnable as a value. So you cannot just pass in the information like this. So I'm going to add a lambda function that is going to return my self-employee information. And this lambda function is going to be coerced into a runnable, okay? Now, third thing is going to be the user input. And right here, we're going to be using the runnable pass-through. Let me just import it right here. So from LangChain core.runnables, we're going to import the runnable pass-through, this one right here. And what's going on right here, the runnable pass-through essentially is just going to pass in whatever we input to the chain as the value of this element right here. And this one, what we're going to pass into the chain is going to be, of course, the user input. Actually, let me just show you how we would use it. So we're going to return self.chain.invoke, and we are going to return whatever is passed by the user input. So this is what's going to be going on right here, if I remember correctly. Yeah. There we go. So that is the first step. Now we are missing another part right here, which is going to be the conversation history. So the conversation history is going to come from the messages. And remember, just like up here, you cannot just pass the messages. You cannot just pass whatever you want to be returned inside a runnable parallel. You have to pass either a runnable or something that can be coerced into a runnable, like a function. So I'm going to, just like before, going to hack around it by using a lambda function that is going to be coerced into a runnable right here. Okay. So that is for the chain, the first step of the chain. This is a runnable parallel with a bunch of things going on. I hope it's clear what's going on right here. And then very easy, we're just going to pass in the prompt, we're going to pass in the LLM, and we're going to pass in the output parser like this. Yeah, there we go. And then by the end, we're just going to return the chain like this. Now, if I am not mistaken, I think this is the entire assistant that we have built. So we have initialized our assistant, we have initialized the properties of the assistant, and we then created the chain. Now this chain is created by taking into account the system prompt, first of all. Then we're creating this prompt that is going to take several variables into it, one of which is the user input, then the conversation history, which is going to be this an array of all of the messages in the history of the conversation. And then inside the prompt, inside the system prompt, we have other variables that are hidden right here. So we have employee information and retrieved policy information. And remember that when you're passing things to a prompt, it has to be in a JSON-like format, in a dictionary. And this is what we did right here with this runnable parallel. So this runnable parallel is returning those four variables. It's returning retrieved policy information, retrieved policy information, the employee information. These two are going to go to the prompt. It is returning the user input, which is just running a runnable pass-through to it, which is also going to go to the prompt, but to this spot right here. And the conversation history, which is going to go to this one right here, okay? So that's what's going on. Then everything right here is sent to the prompt template, which creates the prompt. Then that is sent to the language model, and that is sent to the output parser. And the output parser is going to return the answer to all of it just by doing this right here. So once we have that, we can successfully go back to our app.py. We can import from assistant. We can import our assistant, and then we can just initialize it right here. So I'm going to say that my assistant is going to equal my assistant, and then the system prompt is going to come from this prompt that we have right here. So from prompts, we're going to import the system prompt and the welcome message. The system prompt is going to be the system prompt. The LLM is going to come from, I'm actually going to initialize it right here too. So the LLM is going to come from chat Groq, which I forgot to import. So from LangChain Groq, we're going to import chat Groq. And this one right here is going to be, just whatever it gets by default. I think it's Mixtral. And then what else we have here? We're going to pass this one right here as the LLM. What else does our assistant require? System prompt, language model, the message history. I told you that the message history, at least for this POC, we're not going to be dealing with it directly inside the assistant class. I know it's not super clean, but we're going to have to make some compromises when we're dealing with Streamlit in this case. When we separate from Streamlit, we're going to be able to deal with things a little bit more production ready. But in this case, the data, the state is going to be, the conversation history is going to be dealt with by the session state. So the first thing that we're going to do is we're going to initialize the customer information. Actually, I'm just going to pass it right here. Actually, this one is supposed to be called customer data, and the welcome message is going to come from this welcome message that we have right here. There we go. So the session state, we're going to be initializing it with the customer information, which is going to be the session state. We're going to store it in the session state, and it's going to be this one right here. Then the messages is going to come from the session state as well. And we're going to be initializing it to just a very quick welcome message. That is going to say this right here. So welcome to the Umbrella Corporation. Your integration into our operations has been noted, etc. Ask me any questions you want, etc. Okay. And this is the two first variables that we're going to be dealing with. So remember that this one right here takes in the message history. So the message history is going to come from the session state. The vector store is going to come from this vector store that we have right here. And the employee information is going to come also from our session state that we have right here. Do we have anything else that we need to add? Employee information, vector store, message history, self, system prompt. I'm pretty sure that's all. So now we have successfully initialized our assistant. Forgot a comma right here. And there we go. So we have successfully initialized our assistant. Just to be clear, what is going on right here? We have initialized it. We have created our assistant class, which essentially creates a RAG chain that takes just the user input, and then it just exposes this getResponse method, which we're going to be able to call from our frontend. And this one right here is going to return the answer from our language model, from the entire chain. And we're just initializing it right here with the system prompt that I showed you before, the language model that I showed you right here, the message history, and the employee information, which come from this data service. It's not a real separate service, but like, you see what I mean? And then the vector store that we initialized right here. And the message history and the employee information are actually dealt with by the Streamlit session state, not by the class itself. But I think that this is clean enough to separate this later if we want to get rid of Streamlit and start using a different front end. And yeah, so now the next step is to actually start creating the front end or the graphical user interface using Streamlit. Okay, so let's actually get to doing that. Awesome. So the next thing to do right now is we're going to be creating the graphical user interface. And in order to do this, actually, how I visualized it when I was creating this is that I was going to be passing in the assistant as a dependency to my Streamlit front end. Of course, I mean, you would have to change things a little bit if you were dealing with a more realistic production scenario. You would, of course, separate the API from the front end, for example. But in this case, what we're going to do is to visualize what we would have to do is if we were initializing our assistant right here and passing in this assistant instance right into the front end. Okay, so let's actually do that right now. So the first thing that I'm going to do is I'm going to come right here. I'm going to initialize a new module called GUI. I don't know how to pronounce that in English, but yeah. So right here we're going to be initializing our Streamlit as st, and so we're going to be initializing our class, which is going to be called assistant GUI, and this one right here is going to be essentially just the front end in Streamlit. So let's just initialize it first of all with the things that we're going to be needing to import into it from outside when we initialize it, okay? So as I told you before, we're going to be passing in the assistant right here so that we can use the get response method that we exposed from it. We're going to be setting the message history to it because we want to visualize the history in the application. We're also going to be passing the employee information. This is not mandatory, but if you want to, I mean, for debugging purposes, to visualize on the left sidebar the employee information of the current employee that you're talking to, you can import this one right here, okay? So yeah, let's actually start by doing this. And something that I try to do when I'm creating an app that uses Streamlit for the front end is I try to visualize it as though it was a React application. I mean, it's of course not the same thing, but I try to separate things into components as much as possible to make it easy to visualize what's actually going on. So I tend to create a render. I mean, this is completely personal, personal way of doing this, but feel free to do however you want. So what I tend to do is I create a render method that just renders the main part of the application. I have first created a sidebar, which essentially just displays the logo on top. Now for the logo, I just querying I'm just getting the Umbrella Corporation logo from Wikipedia because why not? Querying, adding a title called Umbrella Corporation Assistant, just a subheader with the employee information, and I'm just displaying the information right here. This is the only place where I'm using the information, by the way, in the front end, because in reality, the employee information is actually being used by the assistant to generate the responses, okay? So in the front end, I am actually only showing it. I'm not using it for any generation. Once I have this, I mean, you could technically turn this into its own component. In my solution, I just didn't do that. So what I did right now is I'm going to render the messages right here. So I'm going to say render messages. And this is going to, of course, require me to create this render messages function. And the render messages is essentially just a loop through our messages like this, up like that. Yep. So I take the messages from the self messages. I could probably just do it like this. But yeah, if the message is from the user, then we create a chat message from Streamlit. Remember that we saw the chat message components from Streamlit as a human and just mark down, mark down the message content. Same thing if the role is AI, I'm going to display it as a content too. This AI right here is important because remember that whenever the message is coming from the AI, it is going to have a property of role assigned to AI, like this, like the first message that we have right here, okay? So now we're rendering the messages right here. After that, we're going to render the user input. So let's say self.render user input right here. we're going to have to create that component right here. I mean, again, you can just write the whole script yourself if you want, if it makes it easier. I just like to modularize it and to be able to visualize the different parts of the UI. So in order to render the user input, I have actually the code right here. Let me show you. There we go. So let me show you what's actually going on right here. So I am initializing the user input to this chat input. Remember that we saw that the chat input component essentially is a component from LangChain, from Streamlit, that displays this very nice chat input input on the bottom, so that can be stored in the messages history. So if the user input is, if the form of the user input is submitted, we're going to, first of all, visualize that chat message in the conversation history. We're going to use st chat message human and then .markdown. This essentially just displays the chat message, as you might remember. And then actually right here, I'm already using streaming. I'm going to mention that in a moment. So here, right here, we're just displaying the response, and then we're assigning we're just updating the history of our conversation in self messages right here. So we're appending the user query, the user question, and then the response. And the response, we are getting it from self.getResponse, which is a function that we have not created yet. And then we have this self-setState function that just updates the session state of the messages history. Now, to visualize it a little bit better, the first thing I'm going to do is I'm going to define the getResponse function. And this one's actually very easy. The only thing that you have to do is create this getResponse function, and it is essentially just going to return whatever the assistant response is. And in order to do this, we're going to call the assistants that we imported from the assistant that we imported when we were initializing this assistant, this frontend. And we're calling the getResponse function from this assistant, which is this one right here. And then we're just calling the user input. Very easy. Now, this right here could technically be, let me just comment this out and say that the response is just going to be this one right here. And actually, this is going to work, if I'm not mistaken. I'm going to show you how to stream it in a moment. And what else are we missing right here? So we have successfully initialized our render messages, render service input, render the messages, render the user input, and oh yeah, the set state function. You technically do not really need this. I just was trying to use set state as little as possible in the entire application to be able to more easily move away from Streamlit later on if you wanted to do that. So I created this set state function like this right here, which essentially just does this right here. It just sets the session state to whatever it is. It's just a wrapper around this thing. Something that you could do instead of this, you could essentially just say st.sessionState messages equals self.messages, and this is exactly the same, and you would get rid of this thing right here. I decided to do it this way. You can just use st.sessionState messages equals self messages as well if you want. It's as you wish. I just try to put session state outside of my component as much as possible, but just, I mean, do as it's easier for you, okay? So there we go. Now, if I'm not mistaken, this should work now. Let's actually just save this and let's go to the browser and execute this to see if the front end is actually working. Oh, something that I forgot is that inside of the application, we are going to have to initialize our graphical user interface. So in order to do this, I'm going to say GUI equals assistant GUI, and then we're going to call the render method, which is this one right here. And of course, I have to import it from from GUI. We're going to import assistant GUI, and there we go. And then, of course, we're passing in the assistant right here as we defined when we would initialize this one right here, that we're initializing the assistant, and the other properties actually come from the assistant itself. So this is what we're going to be doing. Let's save this and let's try to execute this to run this to see how it looks like in the browser. All right, so here we're back, and let's actually start by trying to run this, okay? So the first thing that you have to do is you're going to go to Streamlit run, and then we're going to run app.py because this is where we are actually rendering our front-end application, our Streamlit app. So let's run this, and let's see if we have any problems. Okay, so the file path data, the umbrella onboarding PDF is not a valid file. And that is true because I had actually forgotten that the file is called umbrella corp policies, not umbrella onboarding. So let's go to our file right here and let's update that. I'm going to save this and I'm going to restart my server. Technically, I could have just reloaded the thing right here. So let's see how this goes. There we go. Okay, so we have our assistant right here. Let me show you. Okay, there we go. Boom. There we go. So let's ask a question. So, what are my responsibilities? Let's see if we have any errors. Did not do what I expected it to do. What happened right here? Did we forget to display the response from the assistant? The GUI set state. Oh yeah, I actually forgot to display the response. So we're going to do sd.write the response like this. And let's just rerun this like this. And there we have the response. Okay, there we go. Sorry about that. So now we have the response, greetings, Jacob King, which is my name right here. And we have everything right here. So what are the punishments for his behavior? And we have an error. Let's see what's going on. So request too large for the model, Mixtral 877B. We have an error here. Let's actually go take a look at our Groq rate limits. And as you can see right here, we are, by default, when you're using Groq and you do not specialize the model, it uses Mixtral 7, Mixtral 8 times 7B. And this one actually has a tokens per minute rate limit of 5,000 tokens. If you want to see what are your current limits, because these are not universal, they change depending on what Groq has available. You can go to your Groq Cloud dashboard, settings, and in right here, you see limits. So we can probably use another model right here. We can use Llama 3.1 and retry this. So we're going to reinitialize the whole thing with another language model. And here we have it. We have the model. It's going to equal Llama 3.1 8B. So let's see, what are my responsibilities? Let's just restart this whole thing. You can see now I am still Jacob King. So let's see, what are some possible punishments? And there we have the response. So Mr. King, as you begin, blah, blah, blah. What else is possible if I make a mistake? Okay, are there any monsters here? Many monsters or zombies here. Let's see, we're not hitting any rate limit so far, any token limits either, so it seems to be going okay. Now, it does make me think about the fact that maybe we went a little bit too far. The fact that we hit the limit with Mixtral so fast, it does make me think that we may have gone too far with the 4,000 chunk size for our context. If we're having a long conversation, this will probably go beyond that. So let's leave it at 2,000. And now we can try to rerun this thing. And as you can see, this is going to reload the vector store because now we have changed the function that returns the vector store. So the cache has to be renewed with a new value of the vector store. So things seem to be working all right. What are my responsibilities? Can I be eaten by zombies here? And I cannot provide information about it. Okay, so great. Um, yeah, there seems to be going something on right here. So actually, let me show you how to stream the generation, because we have successfully the chatbot working. But I wanted to show you how to stream it. We have already done that before, and that's actually doing this thing that I had commented out before. So we're going to initialize the generator, returning the getResponse method as well. And this method, we're going to change it in a moment so that instead of returning the complete response, it returns a generator. So it yields every token as it is being generated. And then, as you might remember from the Streamlit part, if we want to stream a generation, you use st write stream, and then whatever that, and then, I mean, this write stream takes in a generator, and whatever this thing returns goes into a new variable that we're going to call response, and this is the one that we're going to append to the message history. So let's save this part right here, and in app, no, it was an assistant, we're going to, instead of using invoke, we're going to use stream like this. We're going to save this, go back to our GUI right here. I don't think we have to restart the whole thing. It's going to reload this. And let's say, what are the worst punishments here? And there we go. It yielded the generation as it was being generated. Can I be eaten by zombies? And yep, so now it gave me a little bit more information. I'm not at liberty to discuss such events. Okay, so this is the chatbot that's working. Let me show you what's going on in the logs of LangSmith. All right, so now let's go to LangSmith right here. Remember that at the beginning of this project, we shown how to use we shown that I had added my LangSmith environment variables to my .env file that will allow my LangSmith account to trace every single thing that is going on in my application, and every time a runnable is executed in my application, it is going to be traced right here. And as you might remember, I added a variable called LangSmith project, and in it I named my project Umbrella Solution, and that's why whatever is going on in that project is traced back to this project Umbrella Solution right here. So let's take a look at the last one. And essentially what's going on right here, remember that in LangSmith you are essentially just tracing everything that every time a runnable is executed in your application, it is going to be shown in LangSmith. And right here you can select show all if you want to show absolutely every single runnable that is in your chains. And in this case, the first runnable, remember, that was a runnable parallel with 4 different elements. The first element was the retriever, which we have right here, vector store retriever. And remember that my entire chain took as input a single thing, which was the user query. So here my query is, can I be eaten by zombies? And the vector store input literally just returned the 4 documents that are the most likely to be relevant to my question. So here are the 4 documents, and here's my query. So there you go. Here I have my runnable lambda, which was the second one. It was a runnable lambda that would essentially just return the data from a user. It did take as input the user query, but it didn't really use it because remember that it was essentially just a lambda function that would return just this right here. And here we have my employee information that was then sent to my prompt. And the third one was just a runnable pass-through, which essentially just worked as an identity function that passed the input to the output under the variable name of user input, like this. And then we have the final runnable lambda, which essentially just returned, the entire history of the whole thing. And in this case, we have that the history is first of all, our message, welcome message. So welcome to Umbrella Corporation, etc. Then we have our user message, which was the previous message in the conversation. As you might remember, the first message that I sent was, what are the worst punishments here? And then it responded this. And then after that, I asked about the zombies. And then let's see all of that. Those 4 variables are actually sent to my chat prompt template. And so here we have everything that was input to it. So we have my user, my customer information, the context information, and the messages that are mapped to the variable conversation history right here. This one is mapped to retrieved policy information, as you might remember. This one is the user information, the history. And the output, as you might remember, is first of all the system message saying you're an assistant from Umbrella Corporation, etc. Then we're passing in the employee information, which is this one right here, which is the one that we retrieved before. Then we have the retrieved policy information from the documents, which are essentially just the documents that we had before. Probably would be a good idea to clean them a little bit. And yeah, we could potentially add a parser function to the chain in order to clean this. This is looking a little bit ugly, but I mean, the LLM is smart enough to understand it. But we should probably clean this, adding an extra step to the chain. And finally, we have the guidelines. Then we go. We send that to our language model, and the language model essentially just responded what we got as a response when we were showing the language model, the application. And then the string output parser essentially just returned only the text from the content of the message. And this is the entire thing that was happening, what's going on. If you want to take a look at the first question that I sent, which was what is one of the worst punishments here, as you can see, we don't have any history right here, but we do have the vector store retriever, which returned the relevant documents for that one. Then the lambda function, which returned the customer information, the client information. And then we have right here the runnable pass-through. So everything seems to be working correctly. Our application seems to be working just fine too. And so we successfully finished this. In the next module, what we're going to be seeing is how to do pretty much the same thing. We're not going to be changing too much the things that the application that we're going to be building, but we're going to be dealing a little bit more closely with the ETL pipeline, or the extraction of the data from our PDF. Because as you might remember, this PDF that I showed you right here was a very easy PDF to parse. In other words, the PDF that we had right here is essentially just text. A real PDF would have like images and tables and would not be like so neatly structured, and that would be much more complicated to parse, and we're going to be seeing how to do that in the next module. So I hope that this video solution was clear for you, and let me know if you have any questions. I'm here to help, and I hope that you enjoyed this exercise as much as I did. See you soon. There you go. So congratulations for completing this project. This is actually one module in the AI engineering bootcamp that I currently host. It is a bootcamp that includes everything you need in order to become an AI engineer and build this kind of AI applications. So basically everything related to chatbots, AI assistants, RAG, MCP, agents, multi-agent systems, everything based on LangChain, LangGraph, and MCP. So if you're interested in that, feel free to join using the link in the description. The community is free with a bunch of different people who are amazing and who are there to help you. You're also going to be able to create connections with them. And we host live Q&As where I personally answer your questions if you have any about the course. So there you go. The link is in the description. Community is free. And then right there, you can also purchase the courses. And your company can also help you purchase the course if you're interested in that. Just send me an email. Thank you very much again for watching, and I will see you in the next one.